Alright, this is my first full-scale test of the MOSFET control circuitry. And before I get to the real test, go over a little bit about my setup here. So I have continuity LEDs over here, and then number 7 there is an alarm LED. That should go off here in a bit. Have a buzzer hooked up to the buzzer when there's an alarm. An alarm condition is anytime there's a control signal trying to turn something on. Let's see, I have a bench power supply here currently putting out 12 volts and 90 milliamps. The continuity circuit takes about 15 milliamps per circuit, and there's 6 circuits, so 90 milliamps there comes out exactly right. Then I've got a 2.2 ohm quarter watt resistor that's likely to become a fuse, going to an oscilloscope on a slow auto roll, monitoring how much current is pulled by the igniters. And then let's see, and the scale on this is 2.2 ohm resistor on a 2 volt scale, so it should be about 1 amp per division. And let's see, maximum indicated there would be 6 amps. We'll see if we go off scale. As a matter of fact, I think I'll lower that down there. I'll give it 7 amps. We'll be able to see on a slow roll. And let's see, anything else here? So first thing I'm going to hook up is the launch signal. I've already gone through all the signals, and none of them cause just one signal, none of them cause a problem. And I'm going to turn off the alarm right after I enable the launch signal. So this is 12 volts going to launch, and you see the alarm light and the buzzer going. I'm going to disconnect that buzzer because I hate it. And just dropped my solder sucker. And let's see. So we now have an alarm condition. There is a signal being sent. First up, on a white wire here is a copperhead igniter. And I'm going to hit copperhead igniter with a ignition signal, so a launch. And here we go in 5, 4, 3, 2, 1. And got no current and no continuity. Hopefully something didn't really go bad, because everything... Oh, there we go. We have max current going through a copperhead that's not lighting. Even though that's saying there's no current at all. Alright, I'm back. As feared, the 2.2 ohm quarter watt resistor was indeed just a fuse, so it blew wide open. And that's why the oscilloscope showed maximum current, because it's no longer 2.2 ohms. It just measured the voltage drop across it, showing 11 volts across it. So, here we go. Take 2. No current limiting resistors. No way to measure the amount of current. Everything is still as was. First, copperhead igniter, which is a white wire. I think it's the second one. Well, it's kind of that one down there. Keeping my fingers away. Here we go with a launch signal in 5, 4, 3, 2, 1. And that was a copperhead. And now I'll do just to have a second one in 5, 4, 3, 2, 1. And that was a different copperhead. And now, just to see if we can launch 2 copperheads at once. Let's see, that should be... And launch being a relative term, we're not flying anything here. I'm untangling some signal wires here in the background. Hopefully I picked the right 2, that I will get 2 copperheads now, the remaining 2 copperheads down in there. Although one of them might have burnt by the other one because it was too close, but here we go. The remaining 2 copperheads. And I got the first fire. I picked the wrong wire. And next one. So that was a Aerotech first fire. Next one, we'll get the remaining copperhead. And now the last one. The last one will be the JTech, which should be... Alright, once more, with the record button running. On the left, we have the Aerotech first fire igniter. I think that's what they call them. And we're going to ignite that in slow-mo here in 5, 4, 3, 2, 1. Awesome! Second up, on the right, we have a JTEC from eMatch, and we're going to ignite it in 5, 4, 3, 2, 1. That's why you cannot use JTECs to start motors. They just go pop. Need something else to work with.